Hey guys, I hope you all are doing good. In the last lecture, we covered some fundamentals about functions. So we covered how functions work in discrete math and a lot of definitions, right? So in this video, we are going to be covering the four different types of functions. So just a quick reminder, if you have not watched the previous video and if you just don't have a good understanding about the function definitions, such as what is a codomain, what is a domain, what is an image and what is a pre-image, etc., I would highly suggest you watch some kind of a video or just try to um, understand all these definitions before watching this video, right? So let's start with the four different types of functions, starting with what is a one-to-one function. So I'll explain each one of these four with an arrow diagram, right? So it's going to make things a lot more easier to understand. So I'm going to draw this function over here. Let's say I have a function a to b, and I have a, 1, 2, 3, and I have b, a, b, c. Okay. Let's start with the first definition, one-to-one functions. So there's two names to it. We can also call it one-to-one, or we can call injective. Now, different universities again use different definitions, but these are the definitions that we basically use in common, right? So a function is injective if every element in the codomain is mapped at most by one element of the domain. Okay, let's try to understand what this means, right? The basic point is, now if you remember the definition of a function, right, I told you guys there's one condition to understand whether something is a function or not. Now that basic understanding is, if I have an element from A, which is the domain, and it points to multiple elements in the codomain, then the clear answer is that it is not going to be a function, right? That's the basic idea about it. Now, the point about injective is that what we want in the case of injective is we don't want one element to be pointing to multiple elements in the codomain. The basic idea is every element in the codomain should be mapped by at most one element of the domain. So I only want this one to only point to a single element in the codomain, right? So I want this one to only point to a single element. I want this two to point to a single element. And I'm talking unique elements, right? This two should not point to this A over here. I want this three to point to a unique element, right? This function, if you look at it, this is going to be injective. Let's try to understand if it's injective from the definition, right? Function is injective if every element in the codomain, so you can see every element in the codomain, A, B, C, is mapped by at most one element of the domain. A is mapped by just one, B is mapped by just two, C is mapped by just three over here. But in the case that 3 was pointing to B instead of C over here, this would not be injective. Why? Because every element is not being mapped by a single element, right? B over here, part of the codomain, is being mapped by 2 and 3, right? So this is the basic understanding of whether a function is injective or not, right? These four are going to be very important to understand if we want to understand what is the inverse of a function. Moving on, so I hope you have a good understanding about what is a one-to-one function. Let's try to understand what is a total function. These two definitions are very easy to understand, right? A function is called a total if every element in the domain has an image. Just a very simple condition that you need to check. So let's look at this function over here. According to the total definition, if every element in the domain has an image, so I look at set A, I see 1 has an image A, 2 has an image B, 3 has an image B. Every element has an image over here, so this is going to be a total function. Just a basic idea. So for a function to be total, there's no like complicated condition that we want it to have or something. Just a very basic condition, every element in the set A should have an image, right? Simple as that. What is the onto function? Moving on. A function is surjective or onto if every element in the codomain has a pre-image. So this is basically just the opposite of what is a total. In this condition, I want every element of the set B to have a pre-image. So if you look at this function over here, right? A has a pre-image 1, B has two pre-images, which are 2 and 3, but C does not have a pre-image, right? So C So this entire function is not surjective. I hope that makes sense. But if I change this over here, right? So let's say this 3 now points to the C over here. If I make this one change, then this would become surjective now. Finally, we have this bijective definition. So a function is bijective if it's total, injective, and surjective. Now let's try to understand all these definitions once again, right? If a function is injective, every element in the codomain is mapped at most by one element of the domain. Basic idea is I have a one element in the domain, it should only point to a single element, right? And every single one element in the domain should have a unique value that they point to. I don't want any of the values in the domain to be pointing to one particular value in the codomain. If there are multiple values, for example, 1 points to A and 2 also points to A, that would be incorrect. That means it would not be injective. It would still be a function, but it would not be injective function, right? So that's a basic, very important thing to understand. Second thing is a function is total if every element in the domain has an image. So if I just need to look at one condition, right? So when you're checking these three conditions, so you've been asked, okay, is this function total or not, or is this function injective, or is this function surjective? You just have to look at that one specific condition for that definition. So if my question is this function total, I should just check if every element in the domain has an image or not, right? So I need to clear all the other things from my mind outside. What basically happens is students confuse the definition of, oh, whether I should look at its injective or not with whether it's total or surjective, right? So whatever you've been asked total, surjective, or injective, just check those conditions one by one. So if question is total, I just need to check all the elements in the domain have an image. Condition is satisfied, hence it's a total function. Same, a function is surjective if every element in the codomain has a preimage. B, every element in B has a preimage. A has 1, B has 2, C has 3. Hence, this is a surjective function. Finally, I can see every element in this set is mapped by one element of the domain, right? 1 points to A, 2 points to B, 3 points to C. Unique elements. So all the elements of the domain point to unique elements. Hence, I can say that this function is injective, surjective, and total, right? So this is going to be a bijective function. Now, why did we understand this, or why bijective function is important? Because next video we are going to be understanding the inverses of functions, and that's going to be a very important topic, right? So I hope you have a good understanding about all these topics, right? I'll be giving a good questions. I'll be giving a bunch of awesome questions on this topic right now, right? So I hope you guys are able to solve it. If not, then I'm going to be solving at the end of the video. So I'll be giving questions on the board now. Hey guys, so I hope you have solved all these questions. If not, these are very tricky questions, so I'm going to solve it, right? Now, before I move on, I think I made a mistake. While explaining injective, I gave a very incorrect definition, so I'm sorry for that. I'm going to explain it one more time, right? The basic idea about injective is that every element in the codomain, so let's say if I have this set A, which points to set B, right? This is a function. Let's say A is 1, 2, 3, and B is A, B, C. The basic idea is all the elements in the codomain over here, A, B, and C, should be pointed to, like they have an arrow pointed towards them by a unique element. So A has an arrow by 1, B has an arrow by 2, C has an arrow by 3. In the case that any of these elements in the codomain have arrows being pointed to by multiple elements in the domain. So for example, B has an arrow pointed towards it by 2 and 3. It would not be injective, right? So that's the basic idea of what is injective. Now, let's try to solve these questions. This is a tricky question. This is the most important one for this lecture as of now. Let f be a function from z to z. So if you don't understand what this means basically means it is a it is a function from the set of all integers to the set of all integers. Now, what is the set of all integers? Z is basically the set which goes from, let's say, like negative infinity, comma, let's say dot 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 minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, till positive infinity. Like the basic idea is it includes all the integers from negative infinity to the positive infinity, right? So this is a function which goes from all the integers to the set of all the integers. What the basic idea is, if this seems like complicated, in very simple words, when I input an integer into this function, it results in an integer, right? That's the basic idea. So I've been given the domain is a set of all integers. Codomain is also the set of all integers, right? It is defined by the function fx equal 3x plus 7, right? So I hope this makes sense. So the basic idea is, let's say I take an integer 1. If I take the integer 1, f of 1 would result in 3, 1 plus 7, which is equal to 10. So if I try to represent this with an arrow diagram, what the point is, let's say I have this set from z to z. If I input the value 1, it basically goes to value 10 in the codomain, right? Let's say if I input 2, it would be 3 multiplied by 2 plus 7, which is 6 plus 7, which is equal to 13. So 2 over here is pointing to the value 13 in this case. I hope that makes sense, right? Okay, so I hope you understand this is a function from the set of integers to the set of all integers defined by fx equal 3x plus 7. Now the question is this injective, is this surjective, and justify why, right? Now let's try to understand injective once again. Just like I said, in the case of injective, all the elements in the codomain should be pointed to by a unique value in the domain, right? So for example, just like I explained with that example, right? So let's try to understand in this case whether that works or not. Do you think every value in the codomain is pointed to by a unique value? Yes or no? I'll try to explain it with this equation. So I have f of x equal 3x plus 7. A simple question that I need to ask myself is, are there any more than one value of x such that 3x plus 7 is equal? Think about it, right? Do you think there are any two values of x such that 3x, x1, let's say I have a value x1, do you think it's possible that 3x1 plus 7 equal 3x2 plus 7 and x1 is not equal to x2? Do you think there's any two integers, x1 and x2, such that 3x1 plus 7 is equal to 3x2 plus 7 and these two integers are not equal? And the simple answer is that's not possible, right? If these two are equal, then x1 should be equal to x2. So the basic idea is this is actually going to be injective. That is, every element in the codomain, which is 3x plus 7 value, should have a unique x value for it. That's the basic idea, right? Since it has a unique value, hence it is an injective function. I hope that makes sense. Now let's try to understand whether this is surjective or not. Now I'm going to explain the definition of what is a surjective once again. Basic idea of surjective is if all the elements in the codomain have a pre-image, then we say the function is surjective. Okay. Now this is a very tricky thing to understand over here. I need you guys to consider a few things in your mind when you're trying to answer this specific question over here. First, what is a domain? Domain is the set of all integers, right? Basic idea. What is the codomain? Again, it is the set of all integers, right? Now, in order to figure out whether this is surjective or not, I need to check it this way. So what I do is, I change this equation the other way around. I write it as y equal 3x plus 7. So if I try to isolate x over here, I get x equal y minus 7 by 3. right? What my point is, when I input the value x, I get y minus 7 by 3. So for every y value that I put in, I'm going to get this x value, or I can write this equation this way as well. Think about, I changed the way that I'm writing this function. Consider the function is y minus 7 by 3 and it's resulting in some value x over here. I hope that makes sense, right? Now I need to figure out whether this is surjective, meaning what I'm trying to figure out is, for all the values of y, is there a unique x value, yes or no? Like for all the values of y, do I have some resulting x value which is present in the domain or not? So I'm going to explain it one more time, what I'm trying to say. I'm trying to find a particular value of x, y, right, which results in a value x such that it is not in the domain. What I'm trying to do is, I'm not going to solve all the values, right? What I'm trying to find is, I'm going to see if there's any particular value which makes this not surjective, right? So let's try to take a simple example. Let's say I take the value 7 in the set of, in the codomain set. If I put the values y7 over here, I get 7 by 7, 7 minus 7 by 3, which results in a 0 by 3. So I get 0. So if the value in the Z set or the codomain is 7, then it is pointed to by a 0 in this case. Now, it's very important to check all the conditions. First, the y value that I input, is that a value of the codomain or not? I input the value 7. 7 is an integer, so I'm inputting the correct value into the equation. That's fine. The resulting value I see is 0. Okay, I find 0. Is 0 an integer or not? Yes, it is. So hence, this example is approved. Right? I hope that makes sense. But now I'm going to take a very specific example, and which will tell why this is not actually surjective. So if I input the value, if I take 5 over here, first I check the condition. Is 5 an integer or not? The condition is satisfied. Yes, it is an integer. Hence, it should be a part of the codomain. So I put y 5 minus 7 by 3 into the equation. But the result value that I get is minus 2 by 3. Now, do you think minus 2 by 3 is an integer, yes or no? And the answer is no. So, what my understanding from this part by solving this equation is that this 5 integer, which is in the codomain, actually does not have a pre-image in the domain, right? So, I have found an element 5 which does not have a pre-image, and since it does not have a pre-image, hence I can say that this function is actually not surjective. So I'm going to summarize this question once again. For injective, I needed to find if every element in the codomain is being pointed to by a unique value, and I find that out. I know very simply, for all the integers, this 3x plus 7 value should have a unique x for it. So if 3x plus 7 is, let's say, 10, it has a unique value 1. If it's 13, it has a unique value 2. So it is injective. For surjective, which means does every element have a pre-image or not, what I did is I checked two conditions. First, I turned the equation around. I wrote it as y equal 3x plus 7 and x equal y minus 7 by 3. I tried to input two values of y, which are of the codomain, and try to check if those values exist in the domain or not, which is I simply try to check value in the codomain if does it have a pre-image or not. And I found out that while 7 had a pre-image 0, 5 does not have a pre-image even though it is part of the codomain. So I found out that there are some values in this codomain which does not have a pre-image, right? Hence, this is not surjective. So this was the most important question from this video. I hope you understand it. Moving on, let's try to solve question number 2. Now, all these questions are going to seem a lot more easier as compared to this one. Given this arrow diagram, is this total, injective, surjective, and bijective? Explain. What was the definition of total once again? All the elements in the domain have an image, right? I see 1 has an image A, 2 has an image B, 3 has an image A, 4 has an image C. I check this simple condition and I find out that it is total. Injective. Is it injective or not? Okay. I see A is being pointed to by 1, but A is also being pointed to by 3 over here. For a function to be injective, all these values A, B and C should have been pointed to by a unique value in A, right? And that is why this is not injective. Is it surjective? Do all the elements in the codomain have a pre-image? And the answer is yes. A has two pre-images, 1 and 3. B has a pre-image 2. C has a pre-image 4. Is it bijective? Since it's not injective, right, it has to be all these three in order to be bijective. So it's not bijective over here. I hope that makes sense, right? Okay, moving on. Let's try to solve question number 4. Given A is 1, 2, 3, 4, B is A, B, C, F, I'm given the function 1 points to A, 2 points to B, and 3 points to C. Is this total? If not, how would you make it total? So I see 1 points to A, okay, 1 has image A, 2 has image B, and 3 has image C. Everything is fine until this point, but I don't see an image for 4 over here. And what is the definition of total? Once again, for a function to be total, all the elements in the domain should have an image. And since this 4 does not have an image, this is not total, right? Now the next question is, if not, how would you make it total? Simple solution is, I'll put down a value or I'll create an image for 4. So I can do that by adding, let's say, 4 points to C as well. Does that make sense, right? Okay, moving on. Let's try to solve question number 4 now. This is also a tricky question, but it's going to be a lot more easier than question number 1. So, given the function from n to n, now this n basically represents the set of all natural numbers. So, just like z is from negative infinity, negative 3, negative 2, 1 to all the positive numbers, natural numbers is basically all the elements from 1 to infinity. Now, there are different ways we represent natural numbers. For some, natural numbers start from 0, and in some definitions it starts from 1. But we're going to stick with the one definition where it starts with a 1, right? So, the question is, so we have basically a function which goes from the set of all natural numbers to the set of all natural numbers, n plus 1, and we have been given this function over here, right? Fn is equal to n plus 1 if n is even, and it is n minus 1 if n is odd. I'll try to explain what this basically means, right? So before I solve a question, it's very important that I understand it, right? Before moving on to this part, I need to understand what this exactly means, and then I'm going to solve this portion. So let's say if n is even, right? So I'm going to start with the first natural number, f1. Okay, 1 is an odd number, and according to this function, if it's odd, then I should do the value minus 1. So I should do 1 minus 1, which is equal to 0. If the value is 2, which is even, I should do n plus 1, which is 3. If the value is 3, I should do minus 1, which results in a 2 over here. Now, so I hope you have a basic idea of how this function is working. Now the question is this injective and is it surjective? Let's try to understand injective over here, right? Injective basically means all the values in the codomain are being pointed to by a unique value in the domain, right? So if you check over here, you'll find out that this is actually going to be injective, right? So if you think about it, for example, f1 is 0, f2 is 3, f3 is 2. All these values which are in the codomain have a unique value in the domain, and hence it is injective. Now let's try to see, is it surjective, yes or no? Surjective meaning, do all the values in the codomain have a pre-image or not? And if you look at this, only these 3 examples very clearly, you'll see a pattern, right? And the answer is hidden in this part over here. And simple answer is actually it is not surjective, right? Natural numbers includes 1 in it, right? But f1 is 0, f2 is 3, f3 is 2. I don't have any pre-image for 1. So if I try to draw this diagram over here, I get 1 points to 0, 2 points to 3, 3 points to 2, and this goes beyond, right? Beyond our explanation. But 1 over here, because so 0 should not be a part over here, and I should just say 1 points to 0. This 1 which comes over here does not have a pre-image, right? And in that is why this is not going to be surjective, right? I hope that makes sense. So these were very tricky questions. If you were able to solve these questions, that is pretty awesome, and you're on a very good pace, right? In the next lecture, we will be covering a bit more complicated concepts and functions and solving more complicated questions. So I'll see you guys in the next video.